Just for an example, and just to be able to inspire us to take a look at why we would like to unit test our functions. Let's say I have a function here, a function that just simply takes in two numbers as an argument and adds them together and puts out their sum. Well, if I went ahead and ran this file, there's no surprise here that the answer we would get is going to be 6. But an interesting question arises is, well, what would exactly happen if I converted this first number here to a string? Well, this is obviously going to result in an error because Python thinks we want to concatenate a string to an integer, which is just completely out of bounds. Hence, it raises this type error. Now, using more skillful techniques like try and except blocks, which is going to be the concept of another video, we can actually manually raise the type of error that we would like to surface from our program. But suffice it to say, an operation like this will raise a type error naturally within the Python programming language, and thus we can actually unit test that when someone puts in a string. We know exactly what is going to happen to help accelerate the debugging process that we might have to go through should something break in a production level environment. Now, lucky for us, unit testing is actually quite simple in the Python programming language, all thanks to the unit test library that is a built-in library when you download the Python programming language. And essentially everything that we are going to cover within this video is going to be self-contained within this unit test module. But let's go ahead and reference the function that we had earlier, right? This function that we called add to numbers. Well, assuming that we define it within our program, the first thing that we are going to want to do to be able to unit test this function is everything that we are going to be testing. We would like to place it within a class. And if you guys don't know how to create a class in Python, I actually created a video on this a couple of weeks back. I'll link that down in the description below. But in order to unit test and to successfully unit test functions using the unit test library, we're actually going to want to wrap all of our unit tests within a class using the following syntax below. First, we are going to want to use the class keyword, indicating that we would like to declare a class object. The next thing we do is provide a name to our unit testing class. Typically, we want to begin it with the word test. And finally, we are also going to want to inherit from the unit test module the test case parent class. And so as a result, we are always going to want to make sure that we use this open and closed set of parentheses and provide the test case class like so within this set of open and closed parentheses. And that's pretty much it for the setup. Everything else is pretty much straightforward. We can go ahead and declare our test cases by simply defining a couple of functions here. And you'll notice the two functions that I have defined. One is sort of the happy use case where everything runs extremely smoothly. And the other case is when we have an issue where an error is occurring, and thus we would like to assert an error is going to be raised. Now, typically in cases where you have like a happy scenario, you can use this assert equal method of the test case parent class to be able to assert the equality between two objects that are returned in your code. And so, for example, knowing that this function adds two numbers, I know that the result and the sum of 2 + 2 is going to be 4. Hence, I want to assert that the result being returned from my function that I'm unit testing is going to be a 4. And similarly, I want to assert that a type error will be raised if I provide a string as an argument to this function that I've defined above. So now this is great. Well, how exactly do we go ahead and run our unit test? Well, there's actually a pretty cool syntax here, which I will go ahead and showcase to you now. Typically, what you're going to want to do is you're going to want to use the if name equals main syntax to be able to run your function. But in order to get all of the test cases above within your test class to run, after you declare the if name equals main line within your script, you're going to want to run what we call a unit test.main method. And essentially what this allows us to do is all the test cases above that we have specified, whether it be 1 or 100, will all be run when we run our file. And just to give you guys an idea what that might look like, if I go ahead and run this file right here, you will notice that the output of my terminal is a bit different than what you might expect. Essentially, what we get is the number of test cases that get passed, the end result of what happened. In this case, indeed, the functionality that I expected was what occurred when I asserted the raise and when I asserted that 4 was going to be equal to the result returned to me by my function. Now, the last concept that we're going to cover in this video is the idea of mocking or patching the results of different functions within your code. And just to give you some context and background on this idea, it is very often the case when using an object-oriented programming language where you're going to be reusing different functions or different methods from different classes within other methods of classes. And sometimes you might have a scenario that only occurs for a very small percentage of use cases that your program actually comes across. And one way you could test this is just by simply running the program when that situation occurs. But a more holistic way to test this is to write a unit test that is always able to run that particular scenario. Now, I know that may be a bit confusing, but the best way really to illustrate this is just by doing an example. So I created a class here. It's just simply called Hello World class, and the function is actually kind of stupid in the sense it only does one thing, where depending on the value that is returned by this function, if a number is greater than 50, it will print hello, and if it is less than 50, it will print world. Now this random number generator function I just defined in this file right here, whereby I just simply use the random library to return a random number between 1 and 100, and this is the function that we actually use within this class. Now I'll go ahead and paste all the code that we are going to need right here, but essentially in addition to just the unit test module, there's going to be two other things we're going to need. We are going to need to import the patch decorator from the unittest.mock sublibrary, and we are also going to need to provide the name of the class that is housing the method we are going to be testing. Again, this first line here is completely identical to what we did before. We go ahead and provide the name of our class, inherit from that unittest.testCaseParent class, but then we can also use this really cool method here called setup. Now this setup function sort of allows us to reference anything we supply it in any other unit test that follows. And so as a result, instead of me having to go ahead and type out this whole hello world class every single time I run my unit test down here, I just simply assign it to a self.hello class attribute, which is just a reference to this hello class object we imported up top. However, how do we use this patch decorator? Well, what we do is we simply use it as a decorator before the function that we define that we would like to unit test, and the first argument that you supply to it is going to be the path to the function you want to unit test. And specifically here, you'll notice that I provide the name of the file that contains the class that I'm going to be testing. This is the method that we're going to be testing right here, but we are also going to supply the function that is being used within the class method, and we are going to specify the return value we would like to have returned. Again, this is because I want to make sure that every time the number is greater than 50, it returns hello, or if it is less than 50, we go ahead and return the result of world. Hence, that's why I've supplied for these two unit tests the values of 51 and 49, because it will force my program to exhibit different behavior. The final thing we always must do when we go ahead and declare this patch decorator is supply whatever value we are returning as a argument to the unit test function for reasons that are a bit more advanced that I would like to get to in this video. But suffice it to say, if you do forget this, you'll get a little warning within your script that you need to supply an additional argument. Thus, I've just simply supplied that the number I'm returning is just a mock number for my unit test to use. And then everything proceeds just as normal, right? I'll assign the results of my function to a variable, and I will like to assert the equality between what I believe it should be and what it actually is. And so if I go ahead and run my program right here, you'll notice that yes, indeed, both of my unit tests pass, because whenever the number is greater than 50 or whenever it is less than 50, I do get the different behavior where either the word hello or the word world is returned. And even if we wanted to just go ahead and check this, I could even actually print out the number after it is mocked to show you guys that every single time we run this, it will be either 51 or 49. And so as you guys can see, right, no matter how many times I run this, it will always be 5149, 5149, even though the function itself is supposed to generate a random number every single time the program is run. But there you have it, you guys, everything you need to know to begin to use the unit test library within the Python programming language to begin to increase your software engineering skills by unit testing the functions or classes that you create within your programs. If you found this video helpful, again, I would really appreciate it if you subscribe, comment down below what your favorite part was, and be sure to smash that like button. If you guys want to continue on and learn more about unit testing concepts within the Python programming language, go ahead and check out the link in the description below for my online software engineering course in Python that I've provided. I've also pinned it in the top comment. Thank you guys so much for watching, and I'll catch you in the next one. See you there.